Welcome to a new session on mathematics. Today we'll be continuing our discussion on polynomials. In the previous class, we had discussed what are polynomials, algebraic expressions, right? Remember? So let's do a brief recap of what we have already learned and then get started with today's topic. So, yes, we had seen the fine difference between algebraic expressions and polynomials, right? And then polynomials of one variable and different on what basis these polynomials are subdivided into categories. What? Based on terms and based on degrees. Based on terms, it is what? Binomial, monomial, right? And then based on and so on. And based on degrees, it is linear, quadratic, cubic, and so on. So today, and then in specific, we started, working with the one variable. What is the generic form of polynomial in one variable? And then what are zeros of a polynomial? What are zeros of a polynomial? So when I say zeros of a polynomial means when it's it indicates that for a particular value of x, it cuts the x-axis or crosses over or touches, whichever way you want to put it. So whenever a graph, right, or should I say, if you're not doing a graphical representation, you're just solving a expression, right? Then what happens? Then if for any value of x, right, if the value of x becomes 0, you're substituting it to be 0 for whatever value, say x minus 2. X minus 2 is equal to 0. So you mean to say that at the value of x equal to 2, the graph cuts the 0, or x minus 2, that is what it means, right? So yes, we have seen that, and we have also seen the remainder theorem, what it means. Now we are moving on today with factor theorem in particular, and then factorization, splitting of middle term, and we'll also see the algebraic identities. So let's get started with the factorization. Definitely we will be in need of remainder theorem, basic knowledge of remainder theorem, right? But still, I'll tell you when we need it. So right now, let's get started with factors. Before factor theorem, I should say, let's understand what are the factors of 6. This is basic understanding that we all have about factors. So when I say what are the factors of 6, what are the factors of 6? So anything that, say 2 into 3 will give me 6, right? So I can say that 2 and 3 are the factors of 6. So now this is a simple number. What if I had an algebraic expression? So what are the factors of this number or a term minus 3x square y? So what are the factors here? It is minus 3, then x. Let me write into here. Minus 3 into x into x into y. These are the factors. So basically whatever is being multiplied here to form a term are called the factors of that particular number. Here in this case it's a term or an expression, right? So yes, let's get started with factor theorem. Now what does this factor theorem say? We all are aware with remainder theorem. What does the remainder theorem say? Let's do a quick recap. Let us write that statement of remainder theorem. What did remainder theorem say? Here, see, this was remainder theorem, right? P of x is equal to x minus a into g of x plus r, right? This was our remainder theorem. Now, this is whenever p of x, so here this was p of x, dividend, divisor was g of x, so let me write it that way itself. So g of x into q of x gives me the remainder r of x or r of a, right? R of a, doesn't matter. So this was our remainder theorem. Now what are we doing here is, say my divisor, instead of writing g of x, we are usually dividing with with in this form, right? X minus a. So let's say that x minus a. So whenever when remainder is 0, what happens to the expression? Let's see. Then what happens? We say that when remainder is 0, we say that x minus a, that is this, my divisor, is a factor of p of x. So basically what are you trying to do here? You equate this to 0. X minus a is being, if I say it is a factor of p of x, it has to be equal to 0. That is what it means. So conversely, what the other way around is, if you are saying x here, there are two steps in this remainder theorem. One is this: when remainder is 0, that means that x minus a is the factor of that p of x or f of x, whatever you want to call. But if x minus a is a factor, first I said remainder, if remainder is 0, then x minus a is factor. Then the converse of that is, if x minus a is a factor, then remainder will be 0. That is what it says, right? So this is the part 2 of it. Okay, so yes. Now we can also prove that how it happens. See here, in first case you're saying what? Remainder is 0, right? So what happens to the p of a? It is 0. Then what happens? Then p of x is equal to x minus a into quotient, that is q of x, because remainder is 0, no point writing it. In the second part, wherein I say that x minus a is a factor, right, is a factor, then what happens? You have to equate it to 0, then x value is a, then I will substitute this in the equation of p of x. What happens? P of a is equal to a, I'm substituting in this, a minus a into q of a, right, plus then p of a is 0, right? Clear? Simple, right? Plus r of a. So let me have the remainder, plus r of a, then p of a is equal to r of a. Clear? So it both means the same, right? I mean, both means the same, but in an opposite way. So initially if you say that yes, x remainder is 0, then x minus a is a factor, right? And if in the second case, that is the converse, if x minus a is a factor, then remainder has to be 0. Okay, that is what it means. Clear? So let's get started with the simple question. So here I have taken an identity, x square minus 1 is equal to x. We all know, right? This is like a square minus b square. What is it equal to? A minus b into a plus b, right? So now find the remainder when x square minus 1 is divided by x minus 1, right? You have to find the remainder. So see here, I can do it by division as well, but here my intention is to use factor theorem. So how do I use? See here, find the remainder when x square minus 1. So this is my p of x. So p of x is equal to x square minus 1. It is divided by what? X minus 1. So if it has to be a factor. So I will equate it to 0. Then the value of x is 1. Substitute, then p of 1 is equal to 1 square minus 1, that is 1 minus 1 is 0. So what is the remainder? Nobody asked you the question. So whenever you divide, the answer that you get is a quotient. You don't get a remainder here, right? No, I mean when you are dividing, it doesn't show the remainder. The final answer is equal to, you would have said x square minus 1. Use the identity, x minus 1 cancels. The answer is x plus 1. No. They have asked here the remainder. So the remainder here is 0. So this is my answer. Clear? Now moving on to next question. examine whether x plus 2 is a factor of given expression. Now, is it a factor? How will we know? Now first for this, what I will do is, let p of x is equal to x cube plus 3x square plus 5x plus 6. Okay, let this is my polynomial. Now we have to check if x plus 2 is a factor or not. If it has to be a factor, it should be equal to 0, right? So x plus 2 has to be equal to 0, or what value of x is minus 2 if it is a factor. Now when I substitute this value into that expression, it has to give me an answer of 0. Only then can I say yes, it is a factor. Otherwise, no. Okay, let's see if I get 0 or not. P of minus 2, wherever x is there, we are replacing it with minus 2. So minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6. Okay, so this is minus 8 plus 4, right? Minus 2 square is plus 4. 4 into 3 is 12 minus 10 plus 6. So let me add up the negative terms and the positive terms. So this plus this is minus 18 plus 12 plus 6 is plus 18. So what is the answer? 0. So therefore I can say x plus 2 is a factor of, you can rewrite the polynomial, or I can just simply say this. Okay, I hope you all have followed. Let's see the next question. Check whether 7 plus 3x is a factor of 3x cube plus 7x. Same thing, right? Let's get started. So p of x here is 3x cube plus 7x. So and this has to be equated to 0. For that, first we have to find the value of x. So how do we do? Transpose 7 to the other side. So 3x is equal to minus 7, or x is equal to minus 7 by 3. Now we know the value of x. Substitute it in the p of x and see if we get the remainder as 0. So let's do it. P of minus 7 by 3 is equal to 3 into minus 7 by 3 whole cube plus 7 into minus 7 by 3. So this is minus 7 by 3 whole cube. Instead of multiplying, let me write this as definitely I need to multiply, right? I cannot simplify it directly. 7 into 7 is 49. 49 into 7 is 343 by 27. Plus into minus is minus 49 by 3. So let's simplify this. 3 ones are, and this is 9 times. So minus 343 by 9 minus 49 by 3. So here, as you all can see, I do not have to further simplify. But if you want to, we will just simplify it because we need to take an LCM here. But as you all can observe, this is definitely not equal to 0, right? It can be simplified further, but do you think I'll get the answer as 0? No. So therefore, I can, by this step itself, I can say that 7 plus 3x is not a factor of p of x. So, but let us simplify for your understanding. So what was it? Minus 343 by 9 and minus 49 by 3. LCM here is 9, right? Minus 343 minus 49 into 3. So this would be minus 343 minus 147 by 9. You get minus 490 by 9. Right? See, we have got a value here. So therefore I can say that x plus 7 by 3. What was that thing? 7 plus 3x, right? 7 plus 3x is not a factor of P of x. You could have, said in the last step itself, in the last thing itself, at this point. I mean, this point. But still, we have seen that on simplification also, the answer did not yield us 0. So therefore, it is not a factor. Okay, let's see a few more questions. Find the value of k. These are the important questions which are usually asked based on factor theorem. So find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k equal to plus k. So basically I have to find this value of k. Let's do it. So how do we do it? Again, first let's assume p of x. You can call it as f of x also. Let me call it as f of x. Is equal to 4x cube plus 3x square minus 4x plus k. Okay. Now they are saying if x minus 1 is a factor, they are saying this is a factor. So x minus 1 is a factor, then value of x is 1. So let's find f of 1. That is 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. So this is 4 plus 3 minus 4 plus k. So what is this equal to? F of 1 should be equal to 0 by factor theorem. So let's simplify. Plus 4 minus 4 cancels. So 3 plus k is equal to 0, or k is equal to minus 3. This is the value of k. Quite simple. These are 1 marker questions in your examinations. Okay, let's see another question. Now, when f of x is equal to x cube plus ax square minus bx minus 8 is divided by x minus 2. Okay, this is divided by x minus 2. The remainder is 0. And when divided by x plus 1, the remainder is minus 30. You have to find the value of a and b. So let's get started. They have said f of x is x cube plus ax square minus bx minus 8. And it is divided by x minus 2. The remainder is 0. So when the remainder is 0, that means that x minus 2 is a factor. So x minus 2 is a factor. X is equal to 2. Then f of 2 is equal to 2 cube plus a into 2 square. Basically, we will have two equations wherein we will have to solve for a and b. Minus 8. So this is 8. This is definitely equal to 0, right? Plus 4a minus 2b minus 8. Plus 8 minus 8 cancels. So 4a minus 2b equals to 0. I can divide this entire equation by 2. So I'll get 2a minus b is equal to 0. Or I can say b is equal to 2a. And I will call this as equation 1. Okay. Let's see another instance wherein, and when divided by x plus 1, the remainder is minus 30. So how do we do this? So x plus 1, right? So x plus 1 is equal to 0, x equal to minus 1. Therefore, f of minus 1 will be equal to minus 1 whole cube plus a into minus 1 whole square minus b into minus 1 minus 8 equal to, here remainder cannot be 0, right? They've given the remainder as minus 30. So let's write that. Now it is minus 1 plus of minus 1 square is plus 1 into a is a, minus into minus is plus b, minus 8 equals to minus 30. So a plus b, minus 1 minus 8 is minus 9 equal to minus 30, or a plus b is equal to 30 minus 30 plus 9. And we know that from equation 1, b is nothing but 2a, right? b is 2a. So a plus 2a is equal to minus how much? 30 and 9 is 21. So 3a is minus 21, or a is equal to minus 21 divided by 3, that is minus 7. If a is minus 7, let's substitute in the previous itself. So b is equal to 2 times of a, that is minus 7. B will be equal to minus 14. So we have found the value of a and b. I hope you all have followed this. So yes. Okay, let's see the next question. Find the roots or find the zeros or the roots of the polynomial p of x is equal to x square minus 5x plus 6. How do we do this? They have not given anything, divided by this or that. So here the simplest thing is by splitting the middle term. How do we do that? Right? How do we do that? See here. Here the coefficients are very important. So what is the coefficient of x square? It is 1. And into the constant, that is 6. So 6 into 1 is 6. Now I have to split the 6 in such a way that I get the answer as minus 5. So what I will do? How can I write this? Minus 6. Okay? Plus 1. What is minus 6 into plus 1? Is minus 5. Right? It gives. This is one way of doing it. The other way is then find the factors. 2 into 3. So factors are 2 and 3. So I can also do this 2 and 3. Now since I want the answer to be plus 6, right? So this has to be minus 2 minus 3. And it has to be equal to minus 5 when I add or subtract. Right? If I add and subtract, it should be equal to the middle term. If I multiply, it should be equal to the coefficients of x square and the constant. Okay? So in this case, minus 6 plus 1 is minus 5, right? But minus 6 plus 1 is minus 6, which is wrong, right? Definitely I got my answer as minus 5. But am I getting this as minus 6? No, it's wrong, right? See here, but here, minus 5. Minus 2 minus 3 is minus 5. Minus 2 into minus 3 is plus 6. Yes, I can consider this and not this. So you need to be very careful when the signs, you cannot just ignore the signs and consider it, right? So this is wrong and this is the one which we'll accept. So how do we write the same expression as? So x square, instead of 5x, I will write it as minus 2x minus 3x plus 6. So take out x as common here. I'll group these two. Okay. Now taking out common. X minus 2. Here I'll take out minus 3. It is again x minus 2. Again x minus 2 is common between the two. So let me take x minus 2 as common. Then what remains? X and minus 3. So x minus 3. So here find the zeros or the roots of the polynomial p of x. Here I can say the zeros or roots of the polynomial are x minus 2 and x minus 3. Clear? Okay. Fantastic. Oh, sorry. The solution was already there. So, yeah. So, this is the thing. What are we doing? Here, the other way of doing here is, see here, this what I explained to you was by splitting the middle term. But here, we have taken a trial and error method. What is a trial and error method? See here, for finding the value of polynomial, I have taken 0. I mean, this is by trial and error. Plus or minus 1, plus or minus 2, right? So, I have expanded that and written. For everything, I have substituted the values, okay? For p of 0, p of 1 and p of minus 1, p of 2, p of... See, basically, what I am doing here is, I have written the factors of 6 here. Okay, not just the random numbers plus or minus 3. These are the factors. So these are the factors. So I have substituted each one. For which value is it becoming 0 is what I need to observe. So as you all can see, for 0 we had a value, for 1 we had a value, for minus 1 we had a value, but definitely for p of 2 and p of minus 2, the answer turned out to be 0. So using factor theorem, I can say that at x equal to 2, p of 2 is 0. Therefore, x minus 2 is a factor of p of x. Similarly, at x equal to 3, p of 3 is 0. X minus 3 is a factor of p of x. Right? What I taught you was by splitting the middle term. But here, this is by using of factor theorem. What do? You consider the constant which is there. Write the factors of it. And then you, by trial and error, find the zeros or the roots of the polynomial. So yes, so x minus 2 into x minus 3, this was the answer that we had got, right? If you remember, I have erased it, but I hope you all remember it. So x minus 2 and x minus 3 are the roots of the polynomial. If I multiply them, I'll get back the same equation. Okay? Now, so yes, so zeros. Right? So you can write this is a generic form of the p of x is x square minus sum of the roots. This is what I was talking about, splitting the middle term. Okay, how does it work? Splitting the middle term, sum of the roots into product of the roots. So you have to, that is what you get. So yes, now let's do this. X square plus 9x plus 18. So what do? What is the coefficient of x square? It is 1, right? And constant. 1 into 18 is equal to 18. So I have to split this 18 such that I get the answer as plus 9. How do I do that? How do I do it? So what do? Let's find the factors of 18. So we have all seen this LCM by division method, right? That's the simplest to find the factors. So 2, starting from the smallest prime number, 2, 9, 3 and 3. So I have to arrange this in such a way that, okay, I have to group this in such a way that the combination should give me, when I add or subtract, it should give me the middle term. The product should give me the coefficient of x square into the constant. This value I should get back. Okay, so let's do. See, there are how many combinations possible? I can group this. 2 3s are 6 and kept alone 3. So when I add them, I'll definitely get 9, and 6 into 3, I will get 18, right? So this is one combination. Or if I group this, 3 3s are 9. 9 into 2 will give me 18, but it will not add up to give me 9. So therefore this combination is not acceptable. So we will go with the first. This will happen only by trial and error, and you have to do a lot of practice here. So let's do it. So x square plus 9x plus 18. So what do? So let's write this. X square plus 6x plus 3x plus 18. Here the position of 6 and 3 doesn't matter. You can write 3x first and then 6x. Okay, whichever way is convenient to you. Next, so x is common, x plus 6. Then in the next, this is the grouping, right? So next one is 3 is common, x plus 6. So x plus 6 is again common. But the final answer will never change, x plus 3. So x is equal to 6. Oh, sorry, x plus 6. Oh, yeah, these are the factors. Correct. Okay. So this is how you find the factorization by splitting the middle term. So let's see the next. Oh, it was already there. Okay. Anyways, so not a problem. X square plus 5x minus 24. So yes, very similar to that. Okay, so you can take this question as your homework. because very much similar. I want to take a difficult question. So for you to verify, the answer should be x plus 8 and x minus 3. Okay, next. Now coefficient of x square is 6 and 3 is the minus 3 is the constant. So it is minus 18. So again find the factors of minus 18 and do that. So what will it be? If I add or subtract, I have to get back 7. In the previous example, we had seen what were the factors of 2 and 3 that we had written. 2 into 3 into 3, right? So what I will do again, I need 7. So one of them can be with the minus sign. 3 3s are, which should be with this minus sign, is also very important. Why? See now, you group this, 3 3s are 9 into 2. Definitely I will get 18. But if I add or subtract, I have to get plus 7. What should I do? I need minus 18, right? So 9 into minus 2 will give me minus 18. When I add them up, 9 minus 2 will give me plus 7. So yes, this is the factors. 6x square plus 7x, that is 9x, minus 2x minus 3. So let's group it. 6x square here, but only 3x is the common. 3x is common, then what do you get? 2 plus 3. So here minus 1 is common. 2x plus 3. So 2x plus 3 into, sorry, here x into 3x minus 1 is here, are the factors here. Okay, I hope you all have followed this. So let's see the next example. It was already there, but yes, we have understood it, right? Now, do I have this? Yeah, fantastic. So I have the solution for this as well. So factorize x cube minus 2x square minus x plus 2. How do we do this? So again, but those were quadratic equations, expressions, right? But here I have a cubic. So how do I simplify this? Definitely I cannot do the splitting by the middle term here, right? Which is the middle term now, right? So what I will do here is I will write all the factors of 2. So what are the factors of 2? Oh, I said the answer is there. So factors of 2 are, factors of 2 is 0, plus or minus 1 and plus or minus 2. So yes, by trial and error, I will substitute these values. Now I don't have to substitute it for everything. If I find one factor, my half job is done. So for here, P of 1, I have got 0. So definitely 1 is the root of this given expression. So it is, one of the factors will be x minus 1. Right? Now, what I can do here is divide this. Divide this given factor expression with x minus 1. So this is the quotient that I get. Okay? So now with this quotient, now I have x square minus x minus 2. Here I will apply the logic of splitting the middle term, which is the easiest. Right? And then remember, we cannot ignore this. This is x minus 1 is also a factor. Okay? Then, so other two factors are x plus 1 and x minus 2. And together, the factors of this particular polynomial is x minus 1 into x plus 1 into x minus 2. I hope you all would have understood. So seeing the next. Using factor theorem, factorize the following polynomial. X cube minus 3x square minus 9x minus 5. So let's do it. Now the factor, what is the factor here? Minus 5, right? So factors of minus 5 are 0, plus or minus 1 and plus or minus 5. So what we will do, f of 1. It's a trial and error, right? F of 1. If I do that, 1 cube minus 3 into 1 square minus 9 into 1 minus 5. Definitely this is not equal to 0. Therefore, x minus 1 is not a factor. Next, if I take minus 1, what will happen? So it will become minus 1 whole cube minus 3 into minus 1 whole square minus 9 into minus 1 minus 5. This is minus 1 minus 3 plus 9 minus 5. Yes, this is equal to 0. Therefore, x plus 1 is a factor. This is minus 1. So it has to be x plus 1 is a factor. Now let's divide that. So x plus 1 divided by x cube minus 3x square minus 9x minus 5. So yes, divided by x square, it becomes x cube plus x square. So minus, subtract, this becomes minus 4x square minus 9x minus 5. This is multiplied with 4x, sorry, minus 4x. This becomes minus 4x square minus 4x. When I subtract, it becomes add and add. This is minus 5x minus 5. So minus 5. So minus 5x minus 5. The answer will be 0. So yes. So the factors are x plus 1, right, equals to into x square minus 4x minus 5. Now, right now we can simplify this by splitting the middle term here. So x plus 1 into x square minus 5x plus 6. So minus 5x plus 6 will give me minus 4x. Minus 5x minus 5 into plus 1 will give me minus 5 if I multiply, right? So minus 5, x plus 1 as it is. So this is x, I will take it out common, x minus 5, let me change the different bracket, x minus 5 into, here it is plus 1. So it is x minus 5. So the factors are x plus 1 into x plus 1 into x minus 1. So these are the factors for the given polynomial p of x. Okay? I hope you all have followed this. Now, moving on to the algebraic identities. Been using the algebraic identities. Here I have taken them in terms of x and y. You usually would have taken it as a and b. So a plus b the whole square is a square plus b square plus 2ab, right? Here I have taken them as x and y. X plus y into x plus y, it will give me is nothing but x plus y the whole square, right? Same way, this is x minus y the whole square, and this is a plus b into a minus b. Okay, and next one is x plus a into x plus b will give me x square plus a plus b into x plus ab. Okay, now write the expanded form. So what I will do here is, I will not do everything here. I want you all to try. I will take up the first and the last. So the other two you will be trying. Okay. So when I say write the expanded form, means basically they are asking us to multiply. So when you multiply x into x, x square, first multiply this and then again this, plus 4x, then take the 10, multiply with the x and then with the 4. So plus 10x plus 4 into 10, 40. So this is x square plus 14x plus 14. Nothing, no difficult, right? It's simple. Now next one, D. These two you people are doing it. Please do try it. So next one is like a plus a square plus a plus b into a minus b. Do not get carried away with the y square here. This is nothing but, if I take y square as a, it is like a plus b into a minus b, right? So on the same lines, this will be y square the whole square minus 3 by 2 the whole square. So this can also be written as y power 4 minus 9 by 4. This is the expanded form of it. Okay. Now, if I have a question, these are the common type of questions that could be asked using identities. Without actual multiplication, find the value of. How do you do it? Here what you could do is, you can write this as 105 into 106 as 100 plus 5 into 100 plus 6. Remember that identity x plus a into x plus b, we will be using that one. So that would be 100 square plus 5 plus 6 into 100 plus 5 into 6. So this would be 100 square is nothing but 10,000 plus 5 plus 6 is 11. 11 into 100 is 1100 plus 6 5s are 30. You add them up. See, in no time we have found the answer. It's such a big number. Multiplying 3 digit into 3 digit is so difficult, but this identities make our job simple. So this would be equal to 11130, right? 95 into 96. What I will do is, next two questions I'll give you the hint how to do. You do the rest. So this would be 90 plus 5 into 90 plus 6. Okay. Next one, 104 and 96. What you could do here is 100 plus 4 into 100 minus 4. Here a square minus a plus b into a minus b identity can be used. Okay. I hope you all can do it on your own. Moving on to the next set of identities. It is x square plus 2xy plus y square into x is equal to, it's the same, right? The other way around I have written, nothing complex. So let's see how do we do this. Factorize the following polynomials. 9x square minus 16y square. What do I do? Now I have to do the reverse. So this is nothing but 3x the whole square minus 16y square can be written as 16 is a perfect square. So minus 4y the whole square. Now using the identity a square minus b square. So this can be written as a plus b into a minus b. Clear? So what I would want you to do is try the others. So yeah, try them. Let me do the D question number. D. X square plus 4y square minus 4y. How do we do this? See here the coefficient of, this has to be 1. There was a small mistake. 1 square or 1, it's the same. 1 plus 4y square minus 4y. It is like, if I have to say, it is like the identity a minus b the whole square. Like, but how? How is it a minus b? Let's see. Let me express that. Okay. The remaining two, again, you take that as a homework. How do we do this? 1 square plus 4y square minus 4y. So this 1 can be written as 1 square plus 2y the whole square. Right? And this 4y can be written as 2 into 2y. Where, or I 1 into 2 into 2y, because this is a, this is b, sorry, this is b. Let me reposition my terms. 2 into 1. Okay, this is 2ab, right? So this will give me 1 minus 2y, or I can say, I can add a minus here. So minus 2y the whole square is nothing but plus 4y square only. So this will be 1 minus 2y the whole square. I hope you all have followed. Simple, right? It is just that you have to position the terms in such a way that you will be able to simplify it. Okay. So this, if I write plus and this as minus. Minus 2ab only, right? Yeah. Now, factorize. So these are the important questions which I felt we struggle when we see a square root. So let me take up the question A first. Okay, so how do we do this? Root 3x square, okay, plus 11x plus 6 into root 3. See, we all know that, let's do the, by splitting the middle term, let's do it and see what do we get. So these are basically, when they say factorize, you go for splitting the middle terms. How do we do this? Root 3 coefficient of x square into constant. So this is 3 into 6. Root 3 into root 3 is 3 into 6 is 18. I have to split this in such a way that I get 11. How do I get? 9 plus 2. 9 2s are 18. 9 plus 2 is 11. So let's do it. Root 3x square plus 9x plus 2x plus 6 root 3. Okay. Now here x is definitely common. Here root 3, this 9 can be written as 3 into 3, right? Instead of writing 3, just 3, I will write root 3 into root 3 into 3. Root 3 into root 3 is 3, 3 into 3 is 9, plus 2x plus 2 into 3 into root 3. So now grouping, now take out the common, root 3x, right? I'll get root 3 plus 3 root 3 plus 2 common here, x. Oh, here I have left one x. So it is 2 is common here. So 2 into x plus 3 root 3. Oh, I've taken root 3 as common here. Sorry. So this is x plus 3 root 3 into root 3x plus 2. Done? Followed? So now I want you to take up the question number B as your homework so that you can get to try with the roots. Okay? Factorize x power 4 minus 3x square plus 2. Now by quadratic, how do we do this? You don't have to worry about it. See here, I have x power 4, I have x square here. So what I will do is, let x square be equal to y. So what will happen to the equation? Y square minus 3y plus 2. Now simplify. Let's use the identity here now. Okay, which identity are we using? The identity of x plus a into x plus b. What did that identity yield us? X square plus of a plus b into x plus ab, right? Remember this identity? Yes, we will be using this identity. How are we using? I'll show you. So y square as it is, okay, plus of this minus 3 can be written as minus 2 minus 1 into, y plus, now a into b, right? Minus 2 into minus 1. Have we used the identity? Yes. See here, minus, wherein my a was minus 2, b is minus 1. So let me write that so that you don't get confused. Minus 2. So plus of minus, this is a, minus 1 is my b. Okay, so what happens here? So I can write this as y minus 2 into y minus 1. I hope you all have followed this. Moving on to the trinomials. So here I have x plus y plus z the whole square. Simply multiply, right? And then do it with y, right? Each and every expression has to be multiplied. So let's do it. X into x is x square plus xy plus xz plus xy plus y square plus zy plus zx plus zy plus z square. On simplification, you get this, right? So yes, these are the next set of trinomials. So let's find out. Write in expanded form. So now basically we are to use the identity x plus y plus z the whole square. Let's use it. Wherein 3a is equal to x, then 4b is y, and 5c is equal to z. Okay, let's do it. So this will be equal to 3a the whole square plus 4b the whole square plus 5c the whole square plus 2 into 3a into 4b plus 2 into y is 4b into z is 5c plus 2 into z is 5c into x is 3a. So what do I get? 9a square plus 16b square plus 25c square plus 3 2s are 6, 6 4s are 24ab plus 4 2s are 8, 8 5s are 40bc plus 10, oh no, 2 5s are 10, 10 3s are 30ca. This is your final answer. Okay. Now write in expanded form. You can take this on the same lines wherein this is a. So a is, sorry, yeah, no, x is 2x here in this case, right? We have taken a x plus y plus b, right? Z, right? So x is 2x, y will be minus y, and z is z. So simple, nothing complicated. I want you all to try that. On the same line here as well, x is 3a, y is minus 7b, and z is minus c. Okay, try this as well. Okay, factorization of trinomial squares. How do we do this? Now, this is the other way around. Okay, the other way, right? Remember, now they have given us the expression. We have to bring it in this form. So how do we do this? First, what I will do here is I'll express this. I'll try to simplify this. 2x square plus 3y the whole square. See here, this is x square, y square plus 16z square is 4z square, 4z the whole square. Then 12xy can be written as, like, I have to want it in terms of this, right? It has the terms x and y, so I'll concentrate on this. So 2 into 2x into 3y will give me 12xy, and 24yz will give me minus 2 into 3y. Here, see, since there is a minus here, so either y or z has to be with the minus sign. So if I say this is with minus sign, 9. See here, z also is, so basically not the y, it will be the z term with the negative sign. So that is how you decide which one you have to allot, the plus or the minus sign. Okay, so 3y into where was I? Yeah, right, this term, right, minus 24yz. So 2 into 3 into minus 4z. Will I get 24? 2 3s are 6, 6 4s are 24, right? This is plus. Plus, again this minus 16xz I have to get. So 2 into x is 2x, and this is minus 4z. So I will get back minus 16xz, right? So this can be written as 2x plus 3y plus minus 4z the whole square, right? Or other words, I can say that 2x plus 3y minus 4z the whole square. This is what you get on simplifying. Okay, now moving on to cubes of binomials. So x plus y the whole cube means it is basically, I'm trying to write x plus y 3 times, right? X plus y into x plus y into x plus y, and then on multiplication I get x cube plus 3x square into 3xy square plus y cube. Here, as you all can observe, 3xy is common. If I take it out, I can rewrite this x plus y the whole cube as x cube plus y cube plus 3xy into x plus y. So let's see a question on this. So to write the expanded form, simple. I'll do 1, you do 1. So 2x cube whole cube plus 1 cube plus 3x xy, right? 3 into 2x into 1 into 2x plus 1. So this will give me 2x, the whole cube is 8x cube plus 1 plus 6x into 2x plus 1. You can further simplify it, but you can leave it at that. Okay. So moving on to the next type of identities, x minus y the whole cube. On the same lines, I can write x minus y as x minus y into x minus y into x minus y. On multiplication, I will get x cube minus 3x square plus 3xy square minus y cube. Now, if I take out 3xy as common, so x cube minus y cube minus 3xy into x minus y. Now let's see one question. So I have to apply the identity here. 5p minus 3q the whole cube, right? So how do we do this? 5p the whole cube, identity, right? Minus 3 minus y cube. So 3q the whole cube minus 3xy. So 5p into 3q into x minus y. Here x is 5p minus 3q. So on simplification, I'll get 125p cube minus 27q cube minus 5 3s are 15, 15 3s are 45p cube into 5p minus 3q. I hope you all have followed this. This brings us I think I'll take one more question here and then end the session. Okay, this is your homework again. Now, these are the kind of questions they will ask you. So how do you do this? I'll do the one. I'll give you the hint for others. Okay, so 104 the whole cube can be written as 100 plus 4 the whole cube. Now use the x plus y the whole cube identity. Same goes with this. This is 100 minus 1 the whole cube, and this can be written as 1000 minus 1 the whole cube. These are the type of questions which could be asked without actual multiplication. Find the product of or find the value of this one. So that is when the identities have to be used. Okay, I've given you the hints and I'm expecting you to take them up and do the homework. Okay, and with this we have come to the end of our chapter polynomials. In today's class we have discussed factor theorem. Basically we started with factor theorem, then splitting of middle term. Whenever they say factorization, so you have to either use factor theorem, or if you could do the if it is a quadratic expression or quadratic polynomial, you simply do the splitting of the middle term. If it is a cubic polynomial that has been asked for you to factorize, first divide them, okay, and then the quotient what you get, then use the splitting of middle term for finding the other two roots, and then total you will have your g of x, that is your divisor is one of the roots, and then when you factorize the q of x, then you get the other two roots. I hope you all have followed, and then we have looked into identities as well and solved few questions based on that. So I'll see you next time with a new topic. Till then, take care. Bye bye.